Well, in typical fashion, I completely recorded a 7-minute video, and I'm using a new microphone. Turns out the microphone didn't work, so I'm using a worse microphone, but I guess it works, so maybe it's actually the better microphone. Regardless, we're going to talk about momentum. So if you look at a good way to see momentum is if you look at these two objects here. On the left, we have a bullet. It says it's moving 100 meters per second. On the other hand, we have a moped here. It's moving at 1 meter per second. The question is, which of the two would be harder to stop? And this is going to be sort of maybe difficult. Some people are going to say, oh, the bullet's harder to stop because it's moving so fast. Other people are going to say this is going to be harder to stop because it's just bigger. And momentum sort of encapsulates this question. And of course, when we talk about which one's harder to stop, we're assuming that we have some sort of device that can capture this bullet, like some sort of Kevlar vest. Not that we'll let it penetrate. Obviously, the bullet can penetrate lots of things, but assuming we had something that could just capture it and stop it, which of the two would be harder to stop? And this is a question that really plays on momentum itself, which is going to be harder to stop. So you can see here is our sort of definition for momentum. Feel free to pause the video here and write that down if you'd like. It says momentum is a quantity of motion of a moving body measured as a product of its mass and its velocity. So you hear momentum around, even in pop culture. It's ironically, you hear it a lot in sports when you talk about momentum. Maybe a team has won 8 of their last 9 games. Well, they're said to have lots of momentum. You're saying, okay, well, they got lots of momentum going in this game. Like they have some sort of factor, this intangible factor that's going to help carry them through this one. And we can see here that momentum is actually fairly simple to calculate. Momentum is the product of mass and velocity. So if you'd like to, you can actually stop the video here and try to figure out the units of momentum. I am going to show you the units of momentum in just 1 second. So if you're confused about that or don't, you should try it out first. But if you can't figure it out, you will see the answer in a minute. But momentum is fairly easy to calculate. It's just the product of mass and velocity. M times V is P, which is momentum. Now, I'm sure you're going to ask me, why is P stand for momentum? And to be honest, I don't really know the answer. I think it comes from Latin, but not certain. So obviously you can't use M for momentum because M is for mass. So I guess that's why you can't use M for momentum. I don't know exactly why it's P. In fact, you should Google that right now. You're on the internet and use Wikipedia or something. Look it up and try to figure out why. You can teach me about it tomorrow. But again, P is what is just standard convention to use for momentum. The standard convention. For some reason, this thing will stop recording sometimes, and I'm not sure why. But anyways, let's calculate momentum. So the question says, how much momentum does a 1,000 kilogram car have if it's moving at 10 meters per second east? Here comes an announcement.
Mr. Ragland,
just ignore it.
Contact the office, please. Mr. Ragland.
All right.
There's anyone in the building that is in pep band.
This is what happens sometimes. This is what happens after school. They just mono announcements. It's just announcements for 30 minutes. All right, how much momentum does a 1,000 kilogram car have? It's moving 10 meters per second. So again, when we calculate momentum, it's fairly easy to calculate. It's just a product of mass times velocity. So in this case, you have a 1,000 kilogram car. Okay, so 1,000 times the velocity is 10 meters per second east. Now, this is really important. Velocity here, let me change colors so I can do this a little better. Velocity is a vector. It has direction. You see here, there's a velocity 10 meters per second east. So we have to include that direction mathematically. Normally, we show the direction using positive or negative. So notice I put down positive 10 because it's going east, and east is traditionally positive. But mass is not a vector. We have a word for things that are not vectors. They're scalars, right? Mass isn't a vector. You wouldn't say that you have a mass of 80 kilograms north or 80 kilograms east. It doesn't make any sense. So this is a scalar and a vector. But when you take a scalar times a vector, so a scalar times a vector, you just end up with, I'll put it over here. You just end up with another vector. So if you take a scalar times a vector, you end up with a vector. So momentum is a vector, meaning that we will have to indicate positive or negative to show the direction. And when you write out the answer, you can give it direction with words. So back here, we've got 1,000 times 10 is obviously just 10,000. But we can't leave this naked number. We got to give some sort of unit. So let's go down here and figure out the unit. Again, if you haven't tried to get the unit yourself, you should do that first. So momentum is going to be, when we do unit analysis, we plug in the units into the equation. So our unit for mass is kilograms times our unit for velocity is meters per second. Well, when we combine these, there's nothing that will really cancel, so we just kind of shove them all together. Kilogram meter per second. And that's what it is. If you remember when we figured out force, it was mass times acceleration, so it looked like kilogram times meter per second squared, and you just got kilogram meter per second squared. But we had a nickname. We called it a Newton, right? We called the units of force Newtons. There is no nickname for the units of momentum. It's just kilogram meter per second. As ugly as that is our unit, kilogram meter per second. And of course, the direction here, because this is positive, the direction would be east. So again, it's very important to remember that momentum is a vector. It's got a direction. Momentum is fairly easy to calculate, but don't forget this. Eventually, we're going to be looking at momentum in 2 dimensions, but momentum is just mass times velocity. You're going to use this, I don't know, like 1,000 times or something. So it's not hard to remember. Mass times velocity is momentum. And what we're really going to be doing with momentum is we're looking at systems of momentum. If we have, let me just do a quick little thing here. Let me show you. What we're going to eventually be doing is we're looking at, okay, if this object is going that way, so this is 10 kilograms, and it's going at 2 meters per second, and then it sticks to this object here, which is 20 kilograms, how fast will they, after the collision, how fast will they move together? This is a problem that we can answer using momentum, because we're going to look at the momentum of a system. This is the system, okay? What is the total momentum of the system here? What will the total system of the momentum of the system be over here? So I think that's all I've really got to say about momentum for now. Again, if you have friends who haven't watched this video, check on them now. Send them a text message right now. I don't care if it's 2 a.m. in the morning. Send it to them. Okay, maybe don't send it to them. It's 2 a.m. in the morning. But get them to watch it, because it is important they understand this for tomorrow. We're going to go right into momentum. So I think that's all I've got. Thank you.